lift, drag and wake turbulence. In the graph on the left, CL versus alpha, the lift curve shows a steady increase in CL with an increase in the angle of attack up to the stalling angle of attack. Beyond the stalling angle of attack, CL decreases rapidly. On the graph on the right, CD versus alpha, CD after a minor initial decline increases steadily as the angle of attack increases. Polar curves. This is a graph of CL versus CD, but there's also a third variable added, which is angle of attack. The polar curve shows the variation of CD as a function of CL. When the angle of attack is increased beyond the maximum lift-drag ratio, CD increases more than CL. In order to find the most efficient angle of attack on the polar curve, a line drawn as a tangent to the curve starting from the axis of origin will show the greatest CL to CD ratio and the corresponding alpha. Factors affecting the lift-to-drag ratio. Wing section has a variable effect. Leading edge devices reduce the lift-to-drag ratio. Low span loading increases the lift-to-drag ratio. A higher mass requires higher speed. In this graph of total drag versus true airspeed, it shows total drag curves, essentially, for different masses of aircraft. The heavy aircraft shows a shift up and to the right of the total drag curve, which increases all the speeds, such as VLRC and VMD. Wing planform. A tapered wing is characterized by a wing chord that decreases from the wing root to the wing tip. Near the wing tip of a tapered wing, the differences in pressure are smaller, causing smaller wingtip vortices, which creates less downwash within the wingspan than a wing with constant chord. Less induced drag is therefore produced, making the wing more efficient, particularly at low speeds. Sweepback and delta wings. On the graph on the left, which is CL versus alpha, to create a given amount of lift, the swept wing requires a higher angle of attack than the straight wing. The delta wing requires an even higher angle of attack. On the graph on the right can be seen the effect on induced drag. At a given angle of attack, the swept wing creates more drag than the straight wing, and the delta wing even more.